Alright guys, so in this video I wanted to talk about another method for dividing polynomials by binomials. And this method is actually, it's faster, but it is also limited to, it's more limited in its applications. So it can actually only be applied to questions where you're dividing by some x plus or minus, or just plus some constant. Okay? So this can only be applied if it's x plus some constant, and this constant can be negative or positive. So you can be adding a negative number to x, or you can be adding a positive number to x. So for example, it could be x plus 2, that works. Or it could be x minus 3, that works, because that's the same thing as x plus minus 3. X plus negative 3 is the same thing. So you're adding a constant anyways. Something that wouldn't work would be x to the power of 3 plus 3. That wouldn't work. Yeah. Or, I mean, technically you could apply it to this, but I would say you probably shouldn't unless you are very confident in it. And usually we don't apply, we wouldn't apply this this method to something being divided by x to a different power. So generally, if it has a power here, don't use that method. I won't be teaching you how to do it. I won't teach you how to identify which situations you can divide if there is an exponent. So basically, it has to be just an x, no coefficient, no exponent. If it was like 3x plus 3, that wouldn't work either. Okay. Yeah, but again, it could work if there was a power, but there would have to be other certain things present in the problem for it to work, and those can be a little bit difficult to identify, and it might just be it's a little bit inconvenient, and it's not really worth it because it's rare that you'll find a problem like that. So generally, if there's a power or if there is a coefficient, do not use this. Again, you could use it with the power, but there are other things that there are other requirements that would have to be met if you were to do it with the power. Okay, so it only works if it's x plus some constant. If you're dividing by x plus some constant. Okay. And also another thing, the polynomial has to be x to the power of y plus some. Actually, I'll talk about that in a second. I'll talk about that later. But basically, right now, just you need to know that it needs to be x plus some constant. So that's what you need to be dividing by. Okay. Right. X plus, yeah. Okay. And we'll talk about why that is later. But let's say we're dividing 3x cubed minus 4x squared plus 3x plus 6 by x plus 2. Okay, so this problem would work because it's x plus some constant, right, where the constant is 2. Okay. So I'm just going to divide this using the method that we used last video, and then I'll explain how we can use the new method to solve this. Okay. All right. So what we would do is we'd write x plus 2 goes into 3x cubed minus 4x squared plus 3x plus 6. Right? X plus 2 is going into this. And in this case where we're dividing by x plus some number, what we have to multiply by x plus 2, like, so we're subtracting some w amount of x plus 2, right? Right? This w right here, it is going to have the same coefficient as this first term, right? It's going to have the same coefficient as this first term. Because the x doesn't have a coefficient, right, in the case that we're doing this for. So it is going to have the same coefficient as the term that its purpose is to get rid of. So it is like we're subtracting w times x plus 2 right now to get rid of this 3x cubed. So the w will have a coefficient of 3. And also, the amount of x's that it has is going to be 1 less than the amount of x, than the power on its x is going to be 1 less than the power on the x of the term that it's getting rid of, right? Because it's being multiplied by an x, so it's going to have a power 1 less than the term that it's getting rid of. So it's going to be 3x squared, because that's 2 is 1 less than 3. Because it's being multiplied by an x already, so it doesn't need one of those x's, because it's supposed to multiply by x to equal 3x cubed, so it's going to have 1 less x being multiplied by it in its original form, and then it's going to multiply by x to equal 3x cubed. Okay, so the power on the variable is going to be 1 less than the power on the variable of the term that it's getting rid of. Okay. So this is going to multiply. This is 3x squared, right? So in this case, remember, it's always going to have the same coefficient as the term that it's getting rid of. It's going to have 1 less. Its exponent is going to be 1 less than the exponent of the term that it's getting rid of, right? Okay. So we can multiply it out. So it's minus 3x cubed minus 6x squared. Okay. That's what we're doing here. So these 3x cubes cancel, right? And this 6x squared is going to combine with this 4x squared, right? So we're going to have minus 10x squared, right? Plus 3x plus 6. Okay. Okay. Then what would our w be now? Well, we know it's going to have the same coefficient as the term that it's getting rid of, right? And we know we have to get rid of this because it has the highest exponent on the variable right now, right? So w is going to equal, in this case, right, when we're getting rid of this negative 10x squared, it's going to equal negative 10. Is it going to be x squared, or is it going to be x? It's going to be x, because it's going to have a power of 1 less than the term that it's getting rid of. So we just figured out what our w is. And the reason I'm going through all this with explaining how the w is related to the term it's getting rid of, well, you'll see why I'm doing that in a second, or later. So that means that we're going to subtract, and then w is going to subtract negative 10x times x plus 2, right? We're subtracting w times x plus 2, and w is 10. It is negative 10x. Okay. So this is going to result in adding 10x squared, right? Because the negatives multiply together. So it's going to result in adding 10x squared, and then it's going to result in subtracting, adding 20x. Okay. And then that is going to result in these 10x squareds canceling out. And now we're going to have 23x plus 6. And this should all be pretty familiar. If it's not familiar, you can go to my other video. And if it's still confusing then, or it doesn't make sense, you can go to Khan Academy, or if you're doing this in school or have done this in school, you can go to your schoolwork. But anyways, we have 23x plus 6, right? That's what we just did using our just regular long division method. And then we would continue. So we would say w in this case, so we don't have the same w anymore. We have a new w, and that w is going to equal just 23, right? Because it's not going to have an x, it's going to have, well, it's really 23x to the 0, right? Because this has a power of 1 on the x, so this would have a power of 0 on the x. So 23 times x to the 0 is just 23. So we're going to subtract 23 times x plus 2. And that is the same thing as subtracting 23x and then subtracting 46. Okay, 23x's cancel. What's 6 minus 46? That is equal to negative 40. So we have a remainder of negative 40. And whoops, I forgot to write all of, so we got 3x squared. I forgot to write my w's at the top. I should have done that. Then we had minus 10x squared. And we had plus 23. And then we have a remainder. We have a remainder of negative 40. So we have a remainder of negative 40. Okay. So our answer would be 3x squared minus 10x plus 23 minus 40 divided by x plus 2. Okay, so that would be our answer to this question. Okay, I'm just making some space, and now we are going to do it using our other method, okay? So what you would do for this method is you would draw this, right? That's just what we draw for this method. And then whatever the constant is, again, this only works for binomials that are like this. So if you look at your binomial, so it only works for binomials that are x plus some constant. So you would look at your constant. In this case, it's positive 2, right? And then you would take the negative of that, okay? And then you would write it over here. So we'd write negative 2, okay? And then you would look at the coefficients of your terms, okay? So in this, so you like there's a 3 here in your polynomial that you're dividing. There's a negative 4 here, then there's a 3 here, then there's a 6 here. Okay, you would write them all out. So 3. Oh, you would. Sorry, you would write them all out. So you would write 3 to represent the coefficient over here. Then you would write negative 4 to represent the second coefficient, and then 3, and then 6. Okay. Then what you would do, is what you would take the 3 down. Just take the 3 down. Would be this, and this 3 would represent the coefficient of your first w. Okay, so remember we wrote our w's are sort of part of our answer, right? So this is how we get the answer. We take down this first coefficient, right? And we know that the coefficient of the first term is going to be the same as the coefficient of the first w, right? So the coefficient of the first w is 3. And then we basically have one of our w's already. We basically have one of our w's already. We know that it's going to be 3x squared from this. Now you might be saying, oh wow, but we don't actually have the x squared there. Well, the thing is, while we were doing this, before we did this, we were given this this right here, right? We were given this question. And the first term we saw had x to the power of 3. So we know that this represents the 3x squared for the w. So we know the first part of our answer is going to be 3x squared. Okay? Now, how do we get the other w's? And you might be thinking, oh, well, the second, or something people might think would be something one might think is that you could just take down this negative 4, and then that would be the next one. But that's not actually true, because we have to take into account this excess term. So I'll go over here. In this example, we produced an excess term. And that changes what the term that we're going to be getting rid of is. So I'll go back here. We can't just say that this negative 4 is going to be the coefficient of our next w, because when we got rid of the first term that we were getting rid of, we got rid of it, there was an excess term, and this excess term changed what the next term was, right? So this negative 6x squared that was produced from getting rid of this 3x cubed changed this negative 4x squared to negative 10x squared. So now we have to get rid of a negative 10x squared. So really what we have to do is we have to find out what the excess term is going to be, and we would write the excess here. So excess term, this is where the excess term would go, okay? The coefficient of the excess term, and then we put these together, and then we would get the second w. So w sub 2, okay? Because basically, negative 4 plus the excess term, so this excess term combined with this negative 4, formed this negative 10x squared, which was the next term that we had to get rid of. And we know that the coefficient of the next term that we have to get rid of is going to be the same as the coefficient of the second w, right? So the coefficient of the term that we have to get rid of now, after the excess term has been combined, is going to be the same as the coefficient of the second w. So we're going to be able to get the second w's coefficient by adding the excess term with the original coefficient of the polynomial. But this original coefficient of the polynomial of the second term is different than the actual one where we subtract a w amount from. We're subtracting w to get rid of this negative 10x squared, even though we started initially with negative 4x squared. So we just need to calculate what this excess term is, right? We have to calculate what this excess term is so that we can find out what the new term was, and we can find out the coefficient of the second w, because those are the same thing. The coefficient of the new term and the coefficient of the second w are going to be the same. So how can we find out what the excess term is? Well, that's where this negative 2 that we drew comes in, okay? We know that this excess term, its coefficient is going to be the same thing as negative coefficient of the w, and I'll explain what I'm doing in a second. Coefficient sub w, coefficient sub w times constant in the binomial, so constant. Okay, so what did I just do? So what did I just write? I just wrote that the excess, actually let me just clean that up a bit, and I'll explain what I just did. Okay, basically, I just wrote that the excess coefficient, let's write coefficient, okay, sorry. Okay. Let's just recap before we continue, actually. So we know that a w is going to have the same coefficient as the term that it's getting rid of, right? So that's why we could just take that 3 down, and we knew that the coefficient of the first w is also going to be 3. Okay. Now we have to find out what the excess coefficient is, right? Because we know that the excess coefficient plus the coefficient of the original polynomial's second term is going to equal the coefficient of the of w, right? Because if you look over here, we had an excess over here. We had excess coefficient. We had this excess, and we added it to this. We had an excess thing, and we added it to this second term to produce a new term that we had to get rid of, right? And we know that this new term that we have to get rid of is going to share its coefficient with w sub 2. So its coefficient is going to be the same as the second w's coefficient. So in order to find the second w's coefficient, all we have to do is find the coefficient of this new term that we produce, which is negative 10 in this case. And it is going to be the excess's coefficient, negative 6, plus the coefficient of the second term, right? So we already have the coefficient of the second term. We just have to find out what the excess coefficient is. Okay? Obviously, we know in this case it's negative 6, but in general, we wouldn't just know that. So we have to find a way that we can get that excess coefficient for all questions without having to write it all out. Now, the thing about the excess coefficient, I just wrote over here, is that this excess coefficient is just going to equal the negative coefficient of w times the constant of the binomial. And we have those two things. We have the constant, which is just 2. And then we have the coefficient of the first w, right? So the excess coefficient produced is going to be the coefficient of the first w, or the w before it, and the constant of the binomial, right? Now, why is that before we apply it? Well, we saw that we had to multiply w by x plus 2, right? So we multiplied w by x plus 2. When we multiplied w by x, we just got the thing that cancels out with the term that we were trying to get rid of. And then our excess term was equal to w times 2. So w times our constant. Now, the reason it's negative this is because we're subtracting it. So we're subtracting it from this polynomial. So it needs to be negative. So negative coefficient of w times the constant. So in this case, it was 3. The w was 3. The constant was 2. So it was 3 times 2 equals 6. And then it was negative 6, right? Because we were subtracting it. So that was the coefficient of the excess term. So we managed to find out what the coefficient of the excess term is. It is negative 6. And you might be seeing why we did the whole negative thing before. We did this negative 2 because it's the negative constant times the coefficient of w. So now we already have a w. Now we already have a negative here. So we're doing negative 2 times 3 to get negative 6. The negative is only here because the excess coefficient is going to equal the negative coefficient of w times the constant. So we have a negative there. Okay? All right. Just so that multiplying this number by this number will equal the excess coefficient. Okay, now we can find out what the w sub 2 coefficient is by adding these two together. Negative 4 plus negative 6 is negative 10, right? And we know that this is going to represent negative 10x because we know that the w is just going to have an x of an x with a lower exponent, lower by 1 of the term that it's getting rid of. So this negative 4 represents negative 4x squared, we know. So this is just going to represent negative 10x. Yeah, because the exponent on its variable is going to be 1 less than the exponent on the variable of the term it's getting rid of. Okay, so we've solved the first two w's using this it's faster, right? We don't have to write quite as much. The only reason it's taking so long is because we're sort of proofing it as we go through, or we're sort of getting an intuition for it as we go through. We're not proofing it. Okay, so then we would just do the same thing as before. We know this old w. Now this is the old w, right? Before this was the old w, but now this is the old w. Is going to multiply by this negative 2 to get positive 20. Okay, so then we get 23. So we add these together. So what I just did was I said, okay, we can get the next excess term, the next excess term's coefficient by multiplying the old w by the constant, or by the negative of the constant, sorry. And that produces the excess coefficient, right? Yeah, the excess's coefficient. Now we know we just have to add the excess's coefficient with the original polynomial's term's coefficient to get the coefficient of the new exponent, the new term, and then we know that new term is going to have the same coefficient as the w. So this represents the w's coefficient. So this is going to represent just 23. Yeah, and so this is just going to represent the w. Okay, so it's the same thing that we did before, except we're just repeating it. And then, so then we would do 23 times negative 2, right, to get negative 46. And then we would get negative 40 over here, right? Wait a minute, we can't keep going, right? Well, this is actually just going to represent our remainder, okay? Because we can't keep going. This just basically represents the last number that we have, right? So this is just going to represent the remainder, because if you think about it, it's just this last term over here. Yeah, so this last term over here that we have to get rid of, subtracted with the last excess, is just going to be the term that we have left over. And we can't get rid of this term anymore, so this is just going to be our remainder. So you see from this method, we managed to get the coefficients of all the w's, and we know what those coefficients each represent. This 3 represents 3x squared because it is underneath the coefficient that represents 3x cubed of the polynomial. So it has 1 less. Its exponent on the variable is 1 less. This is going to be minus 10x. Because it's minus 4x, it's beneath minus 4x squared, it's going to have an exponent on the variable 1 less, and so on. And then we know this is just going to be our remainder. Okay? So we managed to solve it just using this method over here. And I know it seems like it took a long time, but it would take much less time if you weren't going through the long division process also, as well as explaining. So why don't we try another question. Yeah. Just to sort of solidify everything. Yeah. Okay, let's say we have 2x cubed minus 7x plus 6, and we were dividing it by x minus 4. Okay? All right. How would we do this just using this really quick method, right? Well, we see this negative 4 over here, right? So we would write positive 4 over here because we know we take the negative of that. Then we would write our coefficient of the first term over here. Then we would write the coefficient of the second term over here. And then we would write the coefficient, or the constant over here. Now we're actually missing something here. Because when we do this, this is meant to represent x to the power of, I don't know, y minus y, okay? Then this second column would represent x to the power of y minus 1. Then this third column would represent x to the power of y minus 2. Then this fourth column would represent x to the power of y minus 3. So what I mean is that all of these coefficients need to represent an x with a power that is 1 less than the last one. So this represents 2x cubed, right? This represents 2x cubed, right? This over here would need to represent something x squared. But it doesn't, because we don't have an x squared, so we didn't write it. So we would just write a 0, okay? So we would write the coefficients of all of the different terms, okay? So we have 2x cubed minus 7x plus 6, but we are missing an x squared here, so we would just say plus 0x squared, okay? Because this column needs to represent an x to the power of 1 less than this one, okay? This right here represents minus 7x. This represents x cubed, so we need an x squared to go in between them. All right, let's say we had the example 3x to the power of 4, right? It doesn't really matter what the, we can do it for all exponents in the polynomial. Plus 3x cubed plus 3x squared plus 3x whoops. What did I just do? Okay. Anyways, sorry about that. 3x plus 3 plus 3x. Okay. And we're dividing this by x plus 3. So, okay. So, what would we do here? Well, first we would see the term of the coefficient on the first term is 3. Coefficient on the second term, also 3. Then another 3, another 3, and then another 3. Okay? All right. Now, we see that our constant is positive 3. So we just take the negative of that and put it over here. Now, we take this 3 down, right? We just put it over here. And then we multiply this negative 3 by this positive 3, put it over here. That represents our excess term, right? Now, adding these together is going to get the coefficient of the next w. So it's going to be negative 6, right? 3 plus negative 9 is negative 6. Negative 6 times negative 3 is just positive 18. We add these together. We get 21. 18 plus 3 is 21. 21 times negative 3 is negative 63. Negative 63 plus 3 is negative 60. Negative 60 times negative 3 is 180. 180 plus 3 is 183. Okay, so we have already solved this, and it was quite quick, you see. It's pretty fast, because we didn't have to do a lot of the writing that we would normally have to do if we were doing long division, our usual long division method. Now we know that this 3 represents an x to the 4th, right? So this 3 in our answer is going to represent x cubed. That means that this is going to represent x squared, x, this is going to be our constant, and then this is going to be our remainder. Okay. So let's write out our answer. We have 3x cubed minus 6x squared plus 21x minus 60, right? And then we have a remainder of 183, so we just divide it by x plus 2. Or x plus 3, sorry. Okay, so you see how that was pretty quick, right? Pretty fast. Now we can, let's try another one. And this one is going to be a little bit different, and we're going to see what we have to do for this one. Let's say we had 2x cubed, 2x cubed plus 3x plus 3. Okay? And we're dividing this by x plus 4. Okay? Now, notice here that we don't actually have an x squared term. Okay? We don't have an x squared term. And I'm actually just going to do the long division so that I can do some explaining later. So I'm going to write out the long division. So first we have 2x cubed plus 3x plus 3. Okay? All right. We're dividing this by x plus 4. Okay. So we're going to subtract w amount of x plus 4's, right? W has to be 2x squared, right? I just, so times x plus 4. Okay. So then that's the same thing as subtracting 2x cubed minus 8x cubed, minus 8x squared, sorry. Okay. So we see that our excess was indeed negative 2 times 4, right? And that's what it usually is. But the problem is, if we were to do our new method, right? So we would write negative 4 over here, negative 4 over here, okay? 2 over here, 3 over here, and then 3 over here, right? Actually, I'll write those a little bit bigger. 2 over here, 3 over here, and then 3 over here. This negative 8x squared, so we would take down the 2, right? 2 multiplied by negative 4, we would put the negative 8 over here. Now we're adding this negative 8 to this 3. But the problem is this 3 represents 3x, and this negative 8 represents negative 8x squared, right? So we can't just put these together to get our next w's coefficient, right? It turns out that this is going to be, well, these are going to cancel, right? And we're going to get negative 8x squared plus 3x plus 3, okay? So this is a problem, right? Because we can't just put these two together, right? So instead, we should really just have a negative 8 as our w, right? Because this is the next term that we have to get rid of. So what we do instead is we draw this. We would say, put the negative 4 here, put a 2 here, a 0 here, a 3 here, and a 3 here. Okay? Now, the reason we put this 0 here is so that this represents the x squared. So our polynomial doesn't have any x squareds, right? So we're basically saying that our polynomial starts with 0 x squareds, and then it actually works. So we take down the 2, right? And then we multiply that by negative 4 to get negative 8. And this negative 8 can combine with this 0 to form a negative 8. because that's really what's happening in this. We're just subtracting 8x squared, and that 8x squared is becoming a term on its own. And then when we get rid of that 8x squared, we're going to produce an excess term that is going to combine with this 3, right? But we need the 0 here to represent the x squareds because we're really just combining the excess term with the x squareds. We aren't combining the excess term with this 3, so it doesn't work that way. We're combining this negative 8 with this negative 8x squared with 0x squared. We couldn't combine this negative 8x squared with this 3x. Okay. So then what we would do, I'll just continue it using our faster method, and then we would say negative 8 times negative 4, that's 32. Okay, then we get 35. 35 times negative 4 is negative 140. Okay. And then this negative 140 plus 3 is negative 137. Okay. All right. So what we would end up getting is 2x squared plus 3. Oh, sorry. Minus 8x plus 35 minus 137 divided by x plus 4. Okay. So I want to stress this fact that if we were given a polynomial on the top that is missing one of the powers for the x, so it's missing like an x squared, or it's missing x cubed, or whatever, it could be missing anything, and it's between two of our terms, right? Like, it doesn't have an x squared because x squared would normally go between the x cubed and the x, right? Then we would just write a 0 as a placeholder for this x squared, because it sort of represents the fact that there are no x squareds in the polynomial. Okay. Oh, but like if there was like this polynomial is missing an x to the 4th, right? But we don't have to add it because it's not between two of our terms. We don't even deal with it anyways, so why would we even write the x to the 4th? But in this case, we will come across an x squared in our excess term. Our excess term is an x squared, so we have to write this 0 so that the excess term can add to something. Yeah, so we only write it if the term is between two things. So in this case, it was missing an x squared, and the x squared normally goes between the x cubed and the x, which it does have. So we write a 0 as in place of the x squared. We wouldn't write a 0 over here to represent x to the 4th because there's no point in doing that. But the reason we wrote the x squared was so that this negative 8, our excess's coefficient, could combine with something to get the coefficient of the next w. Okay, so that pretty much concludes this video. Thank you.